What's up, guys? Welcome to session 10 of the Linux Bash Scripting Intermediate Level course from coding-bootcamps.com. As always, I am your instructor, Kevin Downs. Today, we're going to be covering performance and porting issues in scripts. Last session, we went over getting data into scripts, manipulating positional parameters with the set, sort, and shift commands, analyzing switches with get ops options, reserved variables, such as opt target and opt individual, and setting default values. This session, we're going to cover improving the performance of your scripts, timing commands in scripts, system resources, setting limits, and portability issues. So let's go and get started with how to improve the performance of some of your scripts. So to do this, you can set the bpx spawn script environment variable to a value of yes. So you can do this in the etc profile, so you can set bpx spawn script to yes in etc profile. Okay, or you can put it in your home/dot profile. Now guys, remember this is a environment variable, home, so this just means your home directory. Now in my case, this would be home kdown/dot profile, okay? We can actually check that out. That may be set in our machines here, and it may not. So we can do a cat/etc/profile. And we're just going to try and grep for that statement to see if it's in there. We're going to do -i bpx. Okay, it looks like it's not in there. Just to be sure there, we're going to go ahead and we're actually going to do a view of that file. Just see what's in there. We'll do a slash and let's just do bpx. Alright, yep, looks like that is not set in there. So what we could do is we could go to the end of this here, and we could even just put in that variable ourselves, okay? Guys, I would really caution you, though, don't mess with this file if you don't know what you're doing, okay? This can really mess things up for you. Okay? So I wouldn't mess with your etc profile file if you're really not sure what you're doing. And the other place we could do it was that slash, or that home variable /dot profile. Excuse me. Let's do a cat of that file. Oops. Okay. And so we have our other file here. Okay, I'm not seeing that bpx spawn script variable in this one either. Okay, so we could also add it in this file. Again, I would caution you to make sure you know what you're doing in those files before you add it. So guys, here's what this variable does. If the spawn callable service determines that a file is not a ZOS Unix executable or a REXX exec, this setting causes spawn to run the file as a shell script directly. In the default processing, however, if the spawn callable service determines that a file is not a ZOS Unix executable or a REX exec, the spawn fails with no exec, and the shell then forks another process to run the input shell script. So, setting the variable to yes eliminates the additional overhead of the fork. So you're saving time when your script runs, okay? You may want to set the variable to no when you're running a non-shell application. For example, if an application does not support shell script invocations, set the variable to no. Likewise, if an application is in test mode, and the returning of no exec would be a useful indication of an error in the format of the target executable file, set the variable to no. Okay? Now we're going to talk about timing commands in scripts. So add time before the command you want to measure, and the output will look like this. Okay, real user insists. So what does real mean? Real is elapsed real time used by the process in seconds, or the wall clock. User is the total number of CPU seconds that the process used directly in user mode in seconds. This one here. Sys is total number of CPU seconds used by the system on behalf of the process in kernel mode in seconds. Okay. So if we go to our virtual box here, we can try that time command. Okay. Time. Let's just do an ls. Okay. And now, if you see, at the bottom here, we have that real user in sys. Okay? So it's 0.003 seconds for the actual real-world time. It was 0.002 seconds that the process used directly in user mode. And it was 0 seconds altogether for sys, which is the total number of CPU seconds used by the system on behalf of the process. Okay. So obviously not much time at all was used by this process, but we can use this when we run a script or anything else to see how long is it actually taking. Is this a very ineffective script that uses up a lot of CPU time, or is it a quick script and we know that it is effective? So we could actually change the script up and see if things we did lowered that time and made it a more effective script. Okay. There's also other ways we can check system resources: top, vmstat, lsof, TCP dump, netstat, htop, iotop, iostat, iptraf, and free-h. I'll show you a few of these. Okay, these can be very helpful. Some of these I use daily. Top, we've talked about many times, is a live view of what's going on in our system. It shows CPU usage, memory usage, the processes running, which user ran them. Okay, we have our CPU load up here, right? Swap, available, memory available, free, used, etc. Okay, so top is a useful one. To get out of top, we hit Q for quit. Remember, top stays there though. You have to clear your screen to get rid of it. We can do a free-h. H stands for human readable, so it puts it in gigabytes and megabytes and kilobytes here. Okay. We can also do a free-g, which is how I prefer to use it. It puts everything in gigs. Okay. So this tells us we have 1 gig of memory, 0 used, 0 free. Okay. Now, you notice this says 0 used and 0 free. That's probably because some is actually being used. Okay, and sure enough, 855 is being used. So there's not quite enough free to equal a gig, and it can't really calculate, you know, smaller than 1 for the gig. So that's all that's going on there. Okay, it's just less than a gig is actually free. Okay. We also have vmstat. Okay, and this kind of shows you CPU usage. So we have swap, free swap, how much is in buffer, how much is cached. You have some other outputs here. You can try htop if it's installed on here. Yeah, htop's not installed. Some of these commands may not be installed on your system. You have to install them. We can try netstat. Again, that one's not installed. But as you see, it tells you what you can do to install them. Okay, so some of these tools, if you want to play around with them, go ahead and install them. They are useful, but top and free are probably going to be the ones that use the most frequently, and lsof is another very useful one. So let's talk about setting limits. So you can actually control the amount of resources a user can use, right? So when you connect to a system, your environment is set up with default limits for stack size, core file size, number of open files, etc. The system sets both soft and hard limits for these parameters. The soft limit is the actual limit imposed by the system. For example, the soft stack limit is the maximum stack size the system will allow a process to use. Users cannot increase their hard limits. Hard limits can be decreased, but is not recommended. The Bourne shell and its derivatives, such as kshell and bash shell, which stands for Bourne again shell, use the ulimit command. The syntax for these commands varies slightly and is shown on the next slide. More detailed info can be found on the man page for the shell you're using. So here we have that ulimit command. You see we have a ton of options and flags we can throw in here, okay? So -s is going to stand for soft, and -h is going to stand for hard. So get capital S, capital H. So the value soft refers to the soft resource limit. This is a limit which may be exceeded if necessary for shorter periods of time, but never exceed the hard limit. The value hard refers to the hard resource limit, and the hard resource limit may never be exceeded under any circumstance. The value unlimited means that there are no limitations on that resource. Okay, and that's going to be -u. If you include the -S or -H option, all other options will refer to that soft or hard limit respectively. If you specify neither or both of these options, then it's going to assume that -S is what you want to set, the soft limit. Some options, but not all, will report the current limit if you omit the limit option. So let's check that out. So I have ulimit here. If I do a --help, it's going to show you what all those flags mean here. Okay. So we have all those flags here. Each one's listed. Okay. So let's do a -v and see if it'll list what the limit is for us. ulimit -v. It tells us unlimited, right? Let's do another one. Let's just do -m. That one's also unlimited, okay? So guys, for this system, everything's probably unlimited for me since it's a very basic machine, right? It's my machine, I set it up, so everything's probably unlimited. If I wanted to set a ulimit, I would do -s, let's say a soft limit, and then I could do -v. And I could say, you know, limit this machine to a certain amount of virtual memory. I'm not going to do it because I don't want to limit it. I want it to stay unlimited. But that is how you would do it. That's a syntax for it. Let's go ahead and head back to our PowerPoint, move on to our next slide, which is going to be portability issues. Okay, so portable to what? What is portability, okay? So that just means, guys, are our scripts versatile and can they be used on other systems with other shells and kernels, okay? So it can be tough to know what your target platforms must be when you first write a script. Do you want the target to be just Linux boxes? Just a specific Linux distribution? System V systems only? There's a lot to be said for developing a broader selection of platforms rather than a narrow one. For instance, one program we used had an installation script that specified /bin/h/sh as its interpreter. It depended on extensions found only in Bash, and the script was developed to run on a Linux system, but apart from this installer, it worked perfectly well in a NetBSD Linux emulation, okay? So in general, the shell's behavior and the behavior of common utilities are governed by the POSIX standard, okay? And guys, I recommend looking up what POSIX is and the standard for it, okay? It's kind of like the Holy Bible or the standard for scripting. So a number of other standards, such as this single Unix specification, may apply, but you can probably do everything you want within the POSIX spec, which is a little more reliably supported. The big thing to watch out for is case shell and bash extensions. For instance, the double bracket and double parentheses syntax found in case shell and bash is not found in ASH-derived shells. Be sure to check your choice of features and syntax against the shell documentation. There are two kinds of shell built-ins you need to be aware of. One is features, which are merely performance enhancements. For instance, many shells have a built-in test to avoid the overhead of launching an external command for every test performed. Okay, remember those test commands are usually going to be those double brackets or single brackets, right? That's how we test a statement. The other kind is commands, such as set or get ops, which must be part of the shell to work at all. So sometimes when we write a script and we use the set and get ops commands, it might not work on other systems. So you have to keep that in mind when you're writing your script and you think it may be used on other systems. So in summary, guys, we talked about improving the performance of scripts, timing commands and scripts, system resources, setting limits, and portability issues. Next session, we have a little bit to go over, a lot of review. We're going to talk about editing a file from a script, scripting with edersed, Unix and Linux utilities manipulate files, regular expressions, grep and egrep, the stream editor sed, sorting in scripts, generating reports with awk, splitting large files, counting words, lines, and characters, transforming file contents, and extracting text strings. Be sure to click on these links and check out our weekly and monthly plans available for private tutoring sessions for system administrator management, as well as some private tutoring sessions for Linux and Bash scripting. Thanks so much for joining me, guys. I'm looking forward to seeing you in our next session.